So what we're going to be talking about today is FileIO. So that's going to be fun and exciting. We're going to do a couple of cool examples here. So why are we talking about FileIO and what is I/O? So first off, I/O stands for input and output, which just means that you are taking information into the program or shoving information out of the program. And when you're doing that to a file, you're going to make it persistent. All right, so normally up until now, every program that you have run pretty much asked the user for some input, they typed something in, it calculated a response, and it printed it back out on the screen because we've been using a lot of console reading and writing, either with system.out.println or with console.writeLine when we're outputting, and the equivalent scanner or read line from the other side to get information in. So the problem with that is that there's no way for the program to persist anything from one run to another. So as soon as the program exits, everything that it knew is lost, which isn't very practical. So a file allows us to read information in from a file, which is better than reading it in from a user in some circumstances, and writing it back out to a file allows us to put our answers in a file. So with this set of mechanisms that we're going to look at today, and with some additional objects, you guys would be able to take input in any format that somebody might give you. So you might say, well, when would this exactly happen? So like, here's a good example. You guys just recently did a test, and we have to get that test out of D2L and put it into Gradescope. And when we do that, when we output it out of D2L, it actually comes out as a Excel spreadsheet. And so then we have to do some munging on it to get it into the right format. But we actually could write some code to read the data that's coming out of that file and then do something with it. So you might have a circumstance where you get some data from somebody, which may have grade information in it, it may have test answers in it, it may have weather information, it may have just a block of, projects that need to be worked on, or nodes, or whatever it might be. Lots and lots of examples of why you might get a file with data in it. And then you might be expected to write a program that does something to that file. Maybe it reads it in and calculates something. Maybe it outputs another file that's similar to it but has some differences in the formatting, or whatever the case may be. So these are real common examples. So reading from a file and writing to a file are something that you'll actually find yourself doing relatively frequently. In this example tonight, we're also going to take a look at reading and writing from things that are not files, which could include the internet. There's actually a chunk of things that you might need to do where you would go out to some other server, get information from it, maybe munge it and write it to a local file or something along those lines. And I'm going to show you a pretty interesting example of that in a few minutes here. So the first thing to know is that when you're dealing with files, you are basically dealing with the same thing that you were dealing with when you were reading and writing from the console. It's not that tremendously different. The concepts are the same. You read in a line, you do whatever you're doing, and you write out a line. The only thing that's different is that you're doing it to a file rather than doing it to a console. So the next statement that we have here is that you have to be comfortable with try and catch, because, and this was the content from the last lecture, try and catch were a way of looking at exceptions that might happen. Well, when you're dealing with files, a lot of different exceptions can happen. So the first thing is, somebody might tell you to open a file name, which is not there. There is no file called a.txt in your local directory. When you try to open it, it's going to throw an exception. So that would not be good. If you don't catch it, the program actually won't compile. It won't let you write something that might have an I/O exception without you putting a try-catch around it. So it's super important that you do this. If you try to compile it without the try-catch, you're actually going to get a compile error saying this method may throw an exception and you didn't catch it. So got to be comfortable with dealing with exceptions. That's definitely important. Okay, so let's talk about streams. These are like little rivers and they have water. Okay, so the reason that we call them streams in the programming term is that they are similar to the real-world idea of a stream, which is there's some amount of data which is flowing either in or out, and we can have input streams and we can have output streams. You've actually been dealing with this since the very beginning of this class, and actually since 1321. The most common input stream is your keyboard. And so anytime that you try to read from system.in or from the console, What you were asking the computer to do was to read from a very specific device called a keyboard. And when the user typed stuff on the keyboard and hit enter, it understood that that was a line, and that's when your read line or whatever it was that you were using to pull the data in, or the scanner, that's how it knew to get the next line out of the stream, which the stream, again, was the keyboard. So all we're really going to do here is we're going to substitute the keyboard for a file when we're doing input. Likewise, every time that you did a system.out or a console.write line, what you were actually sending it to is a device called the display. And you have been, up until now, only just expecting that anything that you did went directly to the screen. Well, another stream that you could use would be a file. And so you can actually, instead of writing it to the screen, you would write it to the file. But again, the way that you do that is actually very, very similar. I just need you to understand that the keyboard, the screen, files, and ultimately something called sockets that we're going to talk about later in the lecture are all examples of streams. And they can all be read from, and they can all be written to. You're used to reading, okay, to be clear, some of those examples are only for reading or only for writing. You cannot read from the screen, and you also cannot write from to the keyboard. Those are not acceptable things. So we have screens, keyboards, files, and sockets. And all of those are readable or writable depending on their particular deal. Another reason that you might throw an exception, going back to the previous thing, is that some files on your file system you may not have permission to read or write from. Some files may be read-only, which means that you can read from it, but you cannot write to it. So if you attempt to write to it, you would get an exception. Some files you may not have permission to at all. They may be owned by another user on the computer. And so these are things that the operating system takes care of for you. It has permission sets, and it only allows you to do certain things. So again, these are other reasons why you might get exceptions when reading from a stream. And it's also possible that you get exceptions while trying to write to a stream if you don't have write permission, or if the file system is full, like if your hard drive is completely full up and you try to write to it, that's not going to be allowed. Likewise, when you're dealing with sockets, the socket may have closed because the server timed out or something along those lines. And again, we'll get to all that in a minute. Okay, so the important part of this slide is think of input and output as streams. And an example of a stream would be your keyboard. That is a input stream. An example of an output stream would be your display, your screen. Okay, so the general process that you're going to work with a file is that you're going to open it, which is something you've never had to do with the keyboard or the display. They are inherently open for you when you run your program. So that's the good news. But if it's anything other than the keyboard or the screen, the first step that you have to do is to ask to open the file so that you can then read from it or write to it or whatever it is that you're trying to do. There are other words here, append and create, which are also important. It may be that you don't want to override everything that's already in the file. You may just want to append some additional information to the bottom of a file, whereas create has the effect of destroying anything that was there and completely making a new file. So that's what those words mean. So once you've got the file open, either for reading or writing, you then would do your reading and writing statements, which are probably something equivalent to console.writeLine or system.out.writeLine, println. And then eventually at the end, you're going to close the file stream. Now, what does it mean to close? It just means that you're done with that file. And it's very important that you call the close operator. If you don't call it when the program ends, it will automatically close the file for you, but there are conditions where you can have too many files open. Actually, your file system has limitations on how many files any given program can have open. So it's very important that when you're done with a particular file, you go ahead and close it out so that it's not in use. Also, your file system prevents more than one person from trying to write to the same file at the same moment. And that's to try and save you some headaches, because if two different people are attempting to write into the same file, then in reality, they're just clobbering each other. So it tries to stop you from doing that. So effectively, while you have a file open, somebody else would not be able to open it, which means that they're going to have to wait until you are done with your program. So the sooner you can free it back up for them, the better. All right, and then I want you to imagine an active cursor. All right, so you're used to the idea, probably at this point, that a cursor is where you are in a program. So like if I were to open up Microsoft Word right now, there's a flashing line at the beginning of the program, and that is where I will type. So as I start mashing keys on the keyboard, the cursor will move across the screen, showing me where the next place is to input. And you're also used to the idea that, of course, you can move the cursor with your mouse to another place, click there, and then start typing there. So I want you to picture when you're doing reading and writing from a file that there is a cursor going on inside the file that's moving around as you read or as you write. It's an important visualization because it'll help you see what's actually going on. All right, so if you're going to read in a file, you need to understand what format the file is in that you're getting data from. And of course, there are many, many different formats that files can be written in. So the simplest answer is that you might just have one element per line. What's an element here? So like let's imagine that I'm reading in a bunch of students' grades. One element might be a student ID and the grade. There might be multiple elements per line. So I might be reading in one line that has every test grade that you have, or every quiz grade, or maybe every test and every quiz grade. And that would mean that that line has many different things in it that I want. So you have to understand when you're reading data in, what format did they give it to you? Today, it's common that you would read in maybe 4 or 5 different formats, we might say. So a comma-separated file is a very common format. So if we go back to my example of my students, I have a student ID, let's say, and then I might have their test 1 grade. So I would have student ID, comma, test 1 grade, student ID, comma, test 1 grade on the next line, and so on and so forth. So every student is one line by themselves, and after the comma, I have their first test grade. There may be more than one comma in there. So for example, I might have student ID, test 1 grade, student ID, comma, test 1 grade, comma, test 2 grade, comma, test 3 grade, comma, final exam grade, or something along those lines. So that's a comma-separated file. And that's usually abbreviated as a CSV. So you frequently see CSV files that get passed around. That's a very easy way to read in information. There are, of course, issues with reading comma-separated files. For example, what happens if a student ID could have a comma in it? Then you're going to have to deal with that situation. Another idea is to do a space-separated file. So instead of using a comma, you would use a space or perhaps a tab. Tab would be the more common one. And so a tab-separated file would be a TSV, tab-separated value. And that's a relatively common one. There are other examples of formats that files might be written in if you're transferring data back and forth. Probably a very common one that's used today is something called JSON, J-S-O-N, and that's not something that we're going to deal with a whole lot in this lecture, but you are going to see it later on in the lecture. It's just a way of putting data in a very specific format so that it's easy to parse, which is the word that you would use when you're pulling information in from a file and having to go through and parse it. And then the final one that I'll mention is an XML file. And that looks very much like an HTML file. So if you've ever written some HTML, you're used to having the little angle brackets around the particular keywords, like bold would be an angle bracket, B angle bracket. So XML allows you to define the tag names inside of there and then have values. And those are all just ways of formatting the data so that it can be read in. So it's important that you understand what format you're getting the data in before you start writing your program, because that will determine exactly what you need to do after you read it in. The last option is that the file might be in a binary format. Now, what does that mean? So everything that I've talked about so far means that it's plain text. And if you're on a Microsoft Windows machine, you have something called Notepad that's installed. Notepad is purely a text editor. It is not a word processor. It's just a text editor. So anything that I've described so far, JSON, XML, comma-separated, tab-separated, all of those would open up in Notepad, and you would be able to see the text directly line by line yourself. However, if you attempt to open up a binary file in Notepad, it's just going to look like a bunch of garbage. It's really not garbage. It's just that Notepad has no idea how to display it because the data inside there is not in text format, it's in some binary format. So what does that actually mean? Well, everything that you've stored in a data structure so far, and like a string would be one example of a data structure, there's some additional stuff that has to be recorded about a string, like how long it is and what the end character is as to how it's being stored in its little data structure. And when we get to some of the other data structures that we're going to look at later on in the module towards the end of the class, you'll see that there's a bunch of other data structures where the data is stored in a particular way. An array would be a good example. We've talked about array lists, and we've talked about a couple of other minor things like that. But those would all be internal structures that were used in memory to store data. It is possible to write some of those structures directly into a file. And as a result, what you get is not plain text, because of course you could be storing numbers, or you could be storing some combination of numbers or other stuff in there. And so the format of that file would end up being binary. If you were to write something in a Microsoft Word document and open that Word document in in Notepad, you'd be quite surprised to find that what's in there is not in any way the words that you wrote. And part of that is because there's a lot of additional information that it has to store as a word processor. It needs to understand what color, what font, how big was the font, is it bold, is it italicized, is it underlined, is it struck through, is it postscript or prescript, is it tab indented or space indented, how far from the margin is it, how big is the page, how all of that information has to be stored inside of your Word document. So the Word document doesn't just store words, which is ironic because that's what you would think it is. It actually stores it all in a binary structure that is very specific to Microsoft Word. And so if you were to try opening a Microsoft Word document in Java and read information in from it, you'd be surprised that you would find a lot of what would effectively look like garbage. So again, you have to know what format it is that you're reading in.